Imagine looking at a sunflower. You see yellow petals around a brown center. Now imagine a bee landing on the same flower. It does not see what you see. It sees a glowing target. It sees stripes pointing inward like runway lights. It sees colors that do not exist in your language. Have you ever wondered what the world actually looks like through the eyes of a bee? Not just whether they see flowers. Not just whether they see us, but what they actually think you are. To a bird, are you family, the highs of a sesame seed? Because the truth is stranger than most people imagine. A bee is not flying through your garden. A bee is flying through a different planet layered on top of yours. And once you understand how it sees, you start to suspect that we are the ones missing something. In 1914, a young Austrian scientist named Carl von Frisch began a series of experiments that would eventually win him a Nobel Prize. He wanted to know if bees could see color. Most scientists of his time said no. They believed bees were tiny biological machines drawn to flowers by smell alone. Von Frisch disagreed. He set out colored cards in a quiet garden, placed sugar water on only one shade, and watched. The bees learned the color. They returned to it again and again, even when he moved it, even when he hid the sugar. That single discovery cracked open a hidden world. Because if bees see color, the next question becomes far more unsettling. Which colors? To answer that, you first have to understand the bee's eye itself. A human eye is a single smooth lens like a camera. A bee's eye is something else entirely. Each of its two large eyes is made of thousands of tiny hexagonal lenses packed together. Scientists call these units ommatidia. A worker bee carries roughly 6,000 to 7,000 of them per eye. Each one captures a tiny slice of the world. The bee's brain stitches these slices together into a low-resolution mosaic. If you tried to read this sentence with bee eyes, the letters would dissolve into blurry pixels. A bee cannot see fine detail at a distance. It would not recognize your face from across a room. But that is not the trade-off it cares about. Because what bees lose in sharpness, they gain in speed. A bee can process visual information almost 5 times faster than a human can. Imagine watching a movie that is playing in slow motion just for you. That is roughly how a bee experiences the air around it. A spinning fan looks like slow propeller blades. A hand swung toward it looks like a lazy approaching wall. This is part of why bees are so frustratingly hard to swat. They are not faster than you. They are seeing your future before you finish moving. Now layer on the colors. Human eyes have 3 types of color receptors, tuned to red, green, and blue. Bees also have 3, but theirs are tuned to blue, green, and ultraviolet. That single shift changes everything. Bees are essentially blind to pure red. A red rose to a bee often looks dull and gray like a dead leaf. This is why so many bee-pollinated flowers are blue, violet, or yellow instead. But the real magic is at the other end of the spectrum. Bees can see ultraviolet light, the invisible radiation just beyond violet that human eyes cannot detect. And flowers, it turns out, have been painting in ultraviolet for millions of years. When researchers photograph a simple yellow flower under UV light, something startling appears. Hidden patterns bloom across the petals. Dark bullseyes, glowing arrows, curved stripes that all point toward the center. Scientists call these nectar guides. To a tass, they are invisible. To a bee, they are flashing neon signs that scream, "Land here." A field of wildflowers through bee eyes is not a soft watercolor. It is an airport. Every blossom is lit up with landing strips and signage written in a language only pollinators can read. And the plants are not decorating themselves for beauty. They evolved this hidden art over millions of years specifically to talk to bees. The flower is advertising. The bee is the customer. And the entire conversation happens in a color we cannot see. But ultraviolet is only the beginning. Bees can also detect something even stranger. They can see the polarization of light. When sunlight passes through the atmosphere, it scatters in patterns that depend on the sun's position. Human eyes are completely blind to this. But a bee's eyes pick up the polarization pattern across the sky like a vast invisible compass. Even on a cloudy day, as long as a small patch of blue is visible, a bee can read the sky. It always knows where the sun is. It always knows which way is home. This is part of how a single bee can fly miles from its hive, visit hundreds of flowers, and return without ever getting lost. Their world has a built-in map written in light. Ours does not. Then there is movement. Because bees process visual signals so fast, motion itself becomes a tool for measuring distance. As a bee flies past objects, it measures how quickly things slide across its vision. Close objects rush past. Distant objects drift slowly. By comparing the speeds, the bee calculates how far it has traveled and how big the world around it is. Scientists call this optic flow. It is the same trick self-driving cars are now learning to use. But bees have been doing it, with a brain smaller than a grain of rice, for over 100 million years. So picture all of this happening at once. A bee lifts off from its hive on a spring morning. The sky above it is not a blank blue dome. It is a glowing pattern of polarized light pointing like an invisible compass. The ground below is not a green carpet. It is a patchwork of ultraviolet beacons, each flower flashing its own private signal. A red car rolls past, almost invisible to the bee. A yellow raincoat, however, glows like a tiny sun. Time itself runs slower. The wind moves like syrup. Every flower it passes is rated, remembered, and mapped in relation to the hive. This is not a small experience. This is a planet of its own. Let me ask you something before we go further. If you have ever watched bees in your own garden or sat near them in a park, have you noticed which flowers they always seem to swarm and which ones they completely ignore? Tell me in the comments which flower the bees in your area love the most. You might be surprised how often it lines up with what scientists already know about ultraviolet patterns. And now back to the strangest part of all. Because seeing is not just about the eyes. It is about the mind that interprets them. For a long time, scientists assumed bees only reacted to colors and patterns by instinct. But recent experiments suggest something more uncomfortable. Bees appear to learn. They appear to remember. And they may even understand abstract concepts. In one famous study, researchers trained bees to recognize the difference between same and different. They were shown two shapes and rewarded when they picked the matching one. The bees figured it out. Then the researchers swapped the shapes for new ones the bees had never seen. The bees still chose correctly. They had not just memorized images. They had grasped the idea of sameness. In other experiments, bees learned to recognize human faces from photographs. Not perfectly, but well enough to distinguish their trainer from a stranger. Other researchers taught bees to roll a tiny ball into a goal for a sugar reward. Bees that watched another bee do it first learned faster. They were not just seeing. They were watching. They were copying. They were, in their own way, thinking. All of this from a creature whose entire brain contains fewer neurons than a single tiny region of your own. It forces a strange and humbling question. If a bee can see ultraviolet patterns we cannot see, read a polarized sky we cannot read, and learn ideas we assumed only mammals could grasp, then what exactly is intelligence? And what else are we missing from the world around us simply because our eyes were never built to notice it? We tend to assume our version of reality is the real one. That the colors we see are the true colors. That the light we perceive is all the light there is. But the bee in your garden is quietly proving otherwise. The same flower you call yellow is, to her, a glowing target on a polarized sky. The same afternoon you call ordinary is, to her, a vivid map of signals, smells, and signs. You walk through your day seeing about 1,000th of what is actually around you. A bee walks through hers seeing a different 1,000th. Neither of you is wrong. But what they view are you stats tuned to different stations of the same vast broadcast. And perhaps that is the most beautiful part of the story. Because once you realize the bee is not living in your world, but a richer, stranger version of it, the small creature buzzing past your ear stops feeling like a pest. It starts feeling like a quiet traveler from a parallel dimension, briefly sharing your afternoon. We share the same garden. We breathe the same air. But we'll leave inside completely different paintings of the same place. So the next time a bee lands on a flower beside you, pause for a moment. You are not just watching an insect. You are watching a tiny mind reading a language of light that your eyes will never speak. If this changed the way you see your own garden, give this video a like so more curious people can find it. Subscribe to Animind for more journeys into the hidden minds of the animals around us. And tell me in the comments, if you could borrow one animal's senses for a single day, which one would you choose and why? Next time we are going to step into the mind of an octopus, a creature so alien that some scientists believe it may be the closest thing on Earth to meeting an intelligent being from another planet. Until then, keep wondering, keep watching, and keep looking at the world a little more like a bee.